Hello, this movie is for learning target 5. Determine whether a parallelogram is a rhombus, rectangle, or square. Our first theorem is if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So one of the most interesting properties of a rhombus is that these diagonals connecting the two vertices that are opposite will be perpendicular. So we get a 90-degree angle here. Then it's a rhombus. So if we can prove that, then we get that these sides are all four going to be the same. If one diagonal of a parallelogram bisects a pair of opposite angles, then it's a rhombus. We know another property of a rhombus is diagonals bisect opposite angles. So what we're saying is if that happens, then we've got a rhombus. Here it's kind of the converse of what we've seen. If the diagonals of a parallelogram are congruent, then the parallelogram's a rectangle. So if we know we start off with a parallelogram and we get that these two diagonals are the same length, then we know we have a rectangle. Can you conclude that a parallelogram is a rhombus, rectangle, or square? So what we have here is this diagonal is bisecting these two angles. So we say yes, we know it's a rhombus. And we know it's a rhombus because in a rhombus, diagonals bisect opposite angles. So that's how we know and can verify that that is a rhombus. On B, what we're given is that all four of these are congruent. And we've got that the two diagonals are perpendicular. So we've got two properties happening. We've got diagonals perpendicular. And that, because that's true, that's a property of a rhombus. And not only that, we have that all four of these are congruent. In a parallelogram, we do get diagonals bisecting each other, but especially in a rectangle, we get that all four of those segments are congruent. And that is because diagonals are congruent in a rectangle. So because this figure is showing properties of both a rhombus and a rectangle, we have that it is a square. Because a square is both a rectangle and a rhombus. Let's go to the next page. Parallelogram has angle measures 20, 160, 20, 160. Can you conclude it's a rhombus, rectangle, or square? And then I also want you to work on 3. Suppose the diagonals of a quadrilateral bisect each other. Can you conclude it's a rhombus, rectangle, or square? Pause the movie, try these 2 on your own, and press play when you are finished. In this first scenario, we could have something that looks like a rhombus. Now, these are not 90-degree angles, so can't be a rectangle, can't be a square. But if this is 160, this is 20, 160, 20, that does seem like it could work, right, for a rhombus? But what if I elongate it? Does that still meet the conditions that are stated? 120, or 160, 20, 160. That does meet the conditions of the angles, but it doesn't appear to be a rhombus, just a parallelogram. So we say, no, we cannot conclude, but we could say it might be a rhombus, but it doesn't have to be a rhombus. Down here, suppose the diagonals of a quadrilateral bisect each other. Now, bisecting diagonals is a property that goes with a parallelogram. So any parallelogram has diagonals bisecting each other. All 3 of these have diagonals that bisect each other. So can we conclude that it's a rhombus, rectangle, or no? Or a square? No, because all parallelograms have diagonals that bisect. Okay, let's go to the next one. Pause this movie, try these two on your own, and then press play when you are finished. All right, number 4 says, for what value of x is, and that is parallelogram ABCD a rhombus? Well, the property of a rhombus that we know is that a diagonal bisects the angles, making these two angles congruent. So if I set 4x plus 8 equal to 6x minus 2, I can solve this for x. I'm going to add 2, subtract 4, and then divide by 2. So when x is 5, this figure is a rhombus. For number 5, what's the value of y that will make this parallelogram a rectangle? Well, what we know is that in a rectangle, diagonals are congruent, and because a rectangle is a parallelogram, we have diagonals bisecting each other, making all 4 of those segments equal. So I set 5y plus 3 equal to 7y minus 5, and I solve this. So I get 2y, and I'm adding 5, I get 8. So this gives me 4 equals y. When y is 4, parallelogram DEFG is a rectangle. All right, pause the movie, try number 6 on your own, and then press play when you are finished. Okay, can you conclude that it's a rhombus, rectangle, or square? So what we have here is that SO, that's a diagonal, is congruent to the other diagonal. Now, because we have diagonals congruent, that is a property of a rectangle. So this guy is a rectangle. Diagonals are congruent. Over here in B, what's being shown is that these diagonals are hitting at a 90-degree angle. So we have diagonals are perpendicular. And because diagonals are perpendicular, we have a rhombus. That is a property of all rhombuses. Let's do number 7. Pause the movie, try these two on your own, and press play when you are finished. For number 7, we're looking at the value of x that makes it a rhombus and a rectangle. So for this first one, a rhombus, the property is all 4 sides are congruent. So when we have 3x plus 9 equal to 8x minus 1, then we have a rhombus. So I'm going to solve this equation. I get 5x here equal to 10, divide by 5. 2 is equal to x. So when x is 2, that figure is a rhombus. And then over here, it's a rectangle, and what we know about rectangles is diagonals bisect each other, property of a parallelogram, and they're congruent because they're a rectangle, making all 4 of those segments equal to each other. So I set 3x minus 5 equal to x plus 1, and I solve this. So I subtract x, I get 2x, add 5, 6, divide by 2, x is 3. So when x is 3, that figure is a rectangle. And that's all for this movie. Thank you for watching.